So what we're going to do is we're going to solve equations that have radicals and rational exponents. They're pretty close to the same thing, so let's go through a couple steps here. Obviously, one of the things you're going to want to do is you're going to want to get the radical or the rational exponent all alone. So say, for example, that you had some equation that had 2 times the square root of x plus 1 minus 3 equal to some number, I'm just going to say 10, you're going to have to add 3 to the other side and then divide by 2 because you want to get the radical all alone. You have to get that all alone like that, all right? So the 2's got to go and this negative 3's got to go, right? Just like we've always done. Similarly, if I had rational exponents, let's say I had 2 times x to the 4/3 minus 5 equal to 10. What we would want to do is we are going to want to get this 5 to the other side. So that's got to cross by adding 5. And we're going to have to get the 2 over there by dividing by 2 also. So this is what we would need to have all alone by itself. One more example of that would be that if I had, let's say I had something like x minus 5 to the 1/2, and let's put a 2 out there, and another minus 5 equal to 10. This part here would have to be all alone. The part with the rational exponent or the radical, and this time the minus 5 is inside the parentheses. I can't get it out of there until, so I've got to move that part over, divide by 2. So everybody understand that? So we're isolating the part with the rational exponent or the radical. Okay, we've got to get that alone. Then what we're going to do is we will raise or take the power to both sides of the equation to whatever the reciprocal is of my rational exponent or the radical. So say, for example, if I had something that was like the cube root of 5 equal to something, let's make this an x, is equal to 5, you would have to take both sides and cube them. Because really what this x in the radical sign is, that's x to the 1/3. So the reciprocal of 1/3 is 3. Since we multiply exponents together, that would be 1/3 times 3 would take that exponent out of there. So whatever the radical is, I do the reciprocal. If the radical is a 3, that means it's really to the 1/3 power. I take it to the 3rd power, both sides. If I have a rational exponent, say I would have x to the 2/3 equal to 10, what I would do is I would have to take both sides to the 3/2 power. And so 2/3 times 3/2, that's 1. So I would get rid of my rational exponent. Okay, so that's the technique we're going to use. And the last thing is, because when I'm doing this, I'm squaring things, and then I'm taking the square roots, or I'm powering, and then I'm rooting. What's going to happen is you're going to create solutions that aren't going to work. Because sometimes you're going to strip a negative off something when you take and square it, and it's going to mean that the answer isn't really going to work. So at the end, you have to plug these numbers back into the original equation and see if it's true. Okay, so let's go ahead and work some of these problems. Okay, so the first problem, what I have here is I have 2 times the square root of x plus 1 equals to 4. So when we look at this, we can see that I need to get this part all alone. So what I'm going to do is I'm going to divide both sides by 2. When I do, I'm going to get this. I'm going to get the square root of x plus 1 is equal to 2, dividing both sides by 2. Now then I need to get rid of that radical sign. That's to the 1/2 power, so I am going to square both sides. This side, the square root of anything squared is just going to pop out, and the other side will be 4. Subtract 1, I got x is equal to 3. Okay, let's see if that's extraneous. So I'm going to check that. You guys need to show the check in your work. So I'm going to check 3. So I've got 2 times 3 plus 1. Is that equal to 4? So I've got 2 times the square root of 4. Is that equal to 4? 2 times 2, is that equal to 4? 4 is equal to 4. Check. So it's a good solution. I'll circle it. Okay, let's do one more of that. Then we'll move on to another kind of problem. Here's one that's got a cube root. So let's give this a shot. So what I need to do is I need to get the radical alone. To do that, I'm going to have to add 1 to both sides. So I'm going to have the cube root of 2x minus 9, and when I add to 1 to both sides, I get 3. Now I'm going to cube both sides to get rid of my cube root. So I would have 2x minus 9 is equal to 27. Adding 9 to both sides, I have 2x is equal to 36. Dividing by 2, I have x equal to 18. I don't know if that's a good solution, so let's try and check it. So I'm going to check 18. Okay, so when I put 18 in there, I'm going to get the cube root of 2 times 18 minus 9 minus 1 is equal to 2. The cube root of 36 minus 9 minus 1 is equal to 2, and that's, is this true? So I've got the cube root of 27 minus 1, is that equal to 2? The cube root of 27, that's 3 minus 1, is that equal to 2? 2 equal to 2. Sure enough, it's good, so I'm going to circle my answer, showing that it's indeed good. All right, now I'm going to move to another kind of a problem that you may see in your you will see in your homework. So what we have here is we have a same kind of problem that we have before, but it's getting a lot more complex, because what we have is before we had a radical or something equal to a number. Now we have a variable on the other side. So watch what's going to happen. So basically what I have is I'm going to just rearrange it. I like to have the actually, I'll leave it like it is. Oops. So I've got x plus 1 is equal to the square root of 7x plus 15. And I have this side is already isolated. Look, there's nothing on this side. So except for the radical, so I can square both sides right at the start. So I'm going to square both sides. Now here's where you guys have to remember that x plus 1 squared, you do not distribute the exponent. That's x plus 1 times x plus 1. All right, so that would be like this. Okay, so I have to do that, and we should know pretty easily what that's going to be. That'll be x squared. This number 1 adds together to give me the middle number, and it multiplies to give me the constant term, right? That's x plus 1 squared. This part, when I square the 7x plus 15 under the radical, it's simply going to be 7x plus 15. Okay, so now I'm going to subtract 7x from both sides. So if I subtract 7x from both sides, I get x squared plus, minus 5x plus 1 is equal to 15. Now I'm going to subtract 15 from both sides, so I'm going to have x squared minus 5x minus 14 equal to 0. And what I end up with is a quadratic equation that I have to solve. So how do I solve a quadratic? Well, I could use the quadratic formula if I couldn't factor it, but this one's factorable. So I'm going to say x minus 7 times x plus 2 is equal to 0. X is equal to 7. X is a negative 2. So we never, ever, ever stop factoring, do we? So I have to check those two answers. One of them may be extraneous. So let's check the 7. All right, so I'm going to check 7. So if I put 7 into that equation, I get 7 plus 1. Is that equal to the square root of 7 times 7 plus 15? So 7 plus 1 is 8. Plus, Is that equal to the square root of 49 plus 15? Is that true? 8 is equal to the square root of 64. 8 equals to 8. That's good, so I'm going to circle it. Let's check the negative 2. Okay, so plugging a negative 2 in, I get a negative 2 plus 1. Is that equal to the square root of 7 times a negative 2 plus 15? That's going to be a negative 1. Is that equal to negative 14 plus 15? Negative 1, is that equal to the square root of 1? Negative 1, is that equal to 1? No. So anytime you see a negative on the outside of a square root like that, you pretty much know it's going to be extraneous, right? So this is not a good solution, and my answer is x equal to 7. That's the only one I have. This would be extraneous. Okay, let's go ahead and do this one. This is going to be, you're going to really enjoy this. Okay, so what we have here is we're going to have to, first thing I'm going to show you is we're going to have, look, I have a radical and a radical on both sides. Now, that isn't what makes this hard. If I have a radical, let's say that this 1 wasn't there. Let's just forget about the 1. I could square both sides, and so I'm just going to do something real quick here, and then let's say that 1 wasn't there. And what I had was x plus 2 is equal to 3 minus x. Then all I'd have to do is square both sides, and I would get x plus 2 is equal to 3 minus x, and I could solve that. So radical equals to radical isn't necessarily bad. But what makes this really bad is the fact that it's got that number 1 there on the radical side. So really what I'm going to do here is this side is already, this side, there's nothing on that side. I could square that side right now, correct? That means I have to square the other side. So you could see that as I square both sides, I actually have a binomial here. So what I'm going to have to do is when I square this side, I'm going to have to go the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. I'm going to have to multiply those two together. All right, so let's go ahead and do this. So what I just showed is that what we're going to end up doing is we're going to end up squaring both sides, and because I'm going to run out of room here, I'm not going to rewrite the equation. So if I take this the square root of x plus 2 plus 1 times the square root of x2 plus 1, my first step is to take, by FOIL, would be take those two terms and multiply them together. So the square root of x plus 2 times the square root of x plus 2 is x plus 2. Now then what I'm going to do is I'm going to take this x plus 2, square root of that, multiply it by this 1. And the next step would be to take this 1 times that square root of x plus 2. So you can see that what I'm really going to have is I'm going to have 2 times the square root of x plus 2. Right? I have 2 square roots of x plus 2 when I do that. Then my last step is simply going to be taking this plus 1 times the plus 1 to give me plus 1. And of course, that's going to be equal to this 3 minus x squared over here. So the square root of anything squared is simply going to be 3 minus x. Okay, so I'm starting to get my equation simplified. So now let's take a look at what I have here. I have x plus 2. So this x, it'll be all alone. This 2 can add to this 1. So I've got x plus 3 plus 2 times the square root of x plus 2 is equal to 3 minus x. Now I need to get the radical all alone. So I could square both sides again. So the first thing I'm going to do is I'm going to say I'm going to subtract 3. So I have x plus 2 times the square root of x plus 2 is equal to negative x. And now I'm going to subtract x from both sides. And that's going to give me 2 times x plus 2 is equal to a negative 2x. Now I'm going to divide both sides by 2. And finally, I'm going to have the square root, let me spread a little, make a little space. The square root of x plus 2 is equal to negative x. Square both sides. When I square both sides, I am going to get whatever's under the square root is going to pop out of there. And a negative x squared is x squared. So now I'm going to rewrite this so that it's a quadratic, and I'm going to move the x squared to the left. Well, actually, let's just leave it like this. 0, subtract x from both sides, subtract the negative 2. I get x squared minus x minus 2. Need one more space. So I can factor that. So I've got x is equal to 2, x is equal to a negative 1. All right, let's see what happens. Let's check those out. Check 2. Okay, so what we're going to have is we're going to have the square root of 2 plus 2 plus 1. Is that equal to the square root of 3 minus, what was I checking? 2? So I have the square root of 4 plus 1. Is that equal to the square root of 1? So I have 2 plus 1 is equal to 1. 3 is equal to 1. No, 2 doesn't work. Okay, let's check a negative 1. Okay, so if I put a negative 1 in there, I get a negative 1 plus 2 plus 1 is equal to the square root of 3 minus a negative 1. I've got, under this square root, I got 1 plus 1 is equal to the square root of 4. I've got 1 plus 1 is equal to 2. 2 is equal to 2. That does work. So the one where it's x is a negative 1 is a good solution, and the x is equal to 2 is extraneous. Okay, let's move on to another kind of a problem. And now we have rational exponents. And so let's give this a shot. We're going to work them the same way we did the other one. We need to isolate the part with the radical or the part with the rational exponent. So this part needs to be alone. So I'm going to add 2 to both sides. So what I'm going to have is after I add 2 to both sides, I have 3x to the 3/4 power is equal to 27. Okay, now then what I need to do is I'm going to take both sides to the reciprocal power. So if I have 3/4, I'm going to take this to the 4/3. I'm going to take this side to the 4/3. All right, so when I take this to the 4/3, this side is going to be 3x. And the other side is going to be the cube root of 27. So what we can do is we can think about it like this. We've got 27, the cube root, then to the 4th power. So the cube root of 27 is 3. 3 to the 4th is 81. So I would have x is equal to 27. Okay, we're running short of time, So you'll need to check that. I don't want to take the time to check it, but you'll have to check that answer, okay? Let's go quickly down to how we're going to set the next one up. And I won't check it either because we are going to run out of time. So what you have to do here is, since this is to the 1/2 power, I'm going to have to square both sides, right? So the reciprocal of the 1/2 would be 2 over 1. So I'm going to say x plus 30 to the 1/2 power, and then I'm going to take that to the 2 over 1 power, which brings me, I have to make one correction to the previous one that I did when the audio was off, is I had a 4 there, that was 4/3. It didn't affect how I worked it, I just didn't write the 3 at the bottom. So anyway, let's go over to this thing again, and I've got, that's going to be then x to the 2's, x squared. So over here, I've got x plus 30 is equal to x squared. So that's a quadratic equation. So we put 0 on this side. Then we're going to have to move everything to the other side. So I would subtract x and subtract 30. And then factoring it, I would have x minus 6, x plus 5. So I could say x is equal to 6, x is equal to -5, and you would have to check those to see if any one of those was extraneous.